So in your student journal, we're going to take notes in a couple different places. Okay, we're going to smush two sections together. But I need you to go to page 135 to begin. Okay. For the next 4 days, we are going to be talking about proving triangles congruent. Okay. Now, we know that if all the corresponding sides are congruent and all of the corresponding angles are congruent, then we have congruent triangles. Okay. But over the course of the next few days, we are going to be talking about some shortcuts. What if we know these pieces of information? Then we're still going to be able to know that we have congruent triangles. Okay. So let's take a step back. Remember, if we're talking about congruent figures, we are talking about two figures that have the same shape and the same size. Okay. Now, we are going to specifically talk about congruent triangles. Okay. So our triangles are going to be the same shape and the same size. Okay. So shortcuts are going to help us prove that triangles are congruent. We are going to talk about 3 shortcuts today and tomorrow. We're going to do the same 3 today and tomorrow. And then we'll talk about 2 or 3 others Wednesday, Thursday. Okay. So our first shortcut is called the side angle side congruence theorem. Really, you need to remember this as side angle side. Okay. What does that mean? That means if we have 2 triangles where we have 2 pairs of sides that are congruent, and the angle in between is congruent, that's not what I wanted, then our 2 triangles are congruent. Okay, so in this picture, we have side, angle, side, side, angle, side. Okay, SAS. The angle has to be in between the sides that we know are congruent. Okay, so we would be able to say, okay, I know that triangle ABC is congruent to what corresponds with A? D, because that's the angle that's congruent. Okay, what would correspond with B? Okay, we would have to go to E because we would have to follow the same pattern with ABC. So ABC, I start at the angle that we know, and then I go along the blue side. So that's what we have to do with the other triangle. Okay. So the biggest thing about this is we have to have that angle in between our 2 known sides. Okay. But if we know a pair of sides and the angle in between, that's enough for us to say, hey, these 2 triangles are congruent because side angle side. Okay. So you're going to draw a picture with me, and we're going to decide if we have triangles that are congruent. Okay. Okay, draw that picture. Do we have triangles that are congruent? Brayden, why? Okay. What do we need in between the two congruent sides? Do we have congruent angles? Oh, we have vertical angles. And what do we know about vertical angles? They're congruent. So now do we have side angle side? Okay. Yes, these are congruent by side angle side. Okay. Side, angle, side. Side, angle, side. Sometimes we are going to have to use our prior geometry knowledge to help us figure out whether we have side angle side. Do you see where this is going? Where's this going? Proofs. Yeah. It's going to be wonderful. Absolutely wonderful. Okay, I want you to draw this picture now. What do you think about this one? Are these two triangles congruent? Who said yes? Why? What property would this be? Let's say this was A, B, C, D. We could say that BD is congruent to itself. What do we call that? That's the reflexive property. Okay, so we know a side is congruent to itself. So now do we have side angle side? Yes or no? Yeah, we could say triangle ABD is congruent to triangle CBD by side angle side. Like reflect instead of reflex. If you accidentally spell it wrong, I probably can be flexible. All right, one more scenario and then we'll do some proofs. All right, what do you think? What'd you say? Between what? So this angle is not in between the two sides. Okay, and I said that was important, right? Okay. Oh, instead we have side angle. Go ahead and read that backwards. Yeah, not allowed. That's not going to happen in this classroom. ASS is not only a bad word, but it is a bad attempt of trying to prove triangles congruent. This is not okay. No, we don't use that word. Okay. So we don't have enough info in order to determine if these two are congruent or not. There is no such thing as side angle, only side angle side. Sound good? Mm-hmm. Go to the next page. I know. Okay. So here's the deal. We want to prove that triangle ABD is congruent to triangle CBD. We know that's going to be our very last step. Okay. Let's just look at the picture. Does it look like we have enough info to get this done?
Yes.
Do we have side angle side? Okay. We do, right?
Because BD is congruent to BD.
Okay, so first of all, they're giving us this information right here, right? All right, well, there's a side. You are telling me that BD is congruent to itself. There's a side. Where are you getting the angle? If this is a right angle, what's the other one? Okay, so right now, we all know that these two are congruent. What we need to do is just make a logical roadmap to get to the end. Okay, so where do we always start?
Given.
All right, so our given is that BD is perpendicular to AC and AD is congruent to CD. And I'm just going to make a little note. Hey, we have right here a statement saying we have sides congruent. Okay. Once we have our side angle side, then we can say we have congruent triangles. So I'm going to go ahead and just make a little note to myself. Ooh, hey. I said a side is congruent. All right. Now, what can we do with BD perpendicular to AC?
We can say that ADB is a linear pair to BDC, and that means since ADB is 90-degree angle, we can say that BDC is also 90-degree angle because they have to add up 100 degrees.
Okay, so since we have perpendicular, what Clark is saying is that these two are 90-degree angles. Is that sufficient? I mean, can we go from perpendicular to two 90-degree angles?
Would that be linear pair?
We would just say definition of perpendicular. We know that perpendicular means we're intersecting at a 90-degree angle. So we could say that the measure of angle BDA equals 90 and the measure of angle CDB equals 90. Definition of perpendicular. All right, have we said that two angles are congruent? Not yet. What do we have to do before we can say that they're congruent?
We could use a reflexive.
Well, we're not there. We're not to the reflexive yet. I have two angles whose measures are 90. Have I said that they're congruent yet? No. Can I say they're congruent right now?
Yes, we can see what they both equal 90, so we could say the measure of BDA is going to measure of CDB.
No, we can't go there yet. We can say that the measures are equal. And what is that? That is substitution. Then once we know the measures are equal, then we can say that they're congruent. And what do we call that? Look at how much you guys are remembering. Hey, now we have an angle that's congruent. We have two more steps. They're the easy ones. We have a side and we have an angle. We need another side. What's our last side? Yeah, we know, and you guys told me this at the very beginning, that BD is congruent to itself by the reflexive property. Okay. I now have three statements in my proof that says we have a side, angle, side that are congruent to each other. So we can now officially say that triangle ABD is congruent to triangle CBD by side, angle, side. Now, before we wrote the proof, you could see that we had two congruent triangles. It was just a matter of getting it laid out in a logical order. Okay. Now, did it have to be exactly this? Not necessarily. You could have used the reflexive property of step 2 and push everything down. That would have been fine. Okay. If you see that right away, put it down. Okay. But these three would have to be in that order. Okay. All right, what I want you to do in number 2, I don't want you to write the proof. We're going to do that together, but I want you and your elbow partner to talk about what we would need to do in order to prove that these two triangles are congruent. Ready, set, go.
We know that triangle is a vertical angle to NML. We can say that the vertical angle is in that angle as the S. So that means JNM or JK equal ML and ML.
All right, I'm going to go ahead and write my first statement is our given. What does our given give us? Yeah, it gives us both sets of sides, doesn't it? Okay, so the only work we have to do is getting the angle in between, right? Here we have side, side.
I mean, we don't really have to figure it out because we know those are vertical angles. So
Okay, so Clark is saying we have vertical angles. Is that was that a part of your discussion with your elbow partner also? Okay. So we have vertical angles. So angle JNK is congruent. If I name it JNK, what's the other angle? Thank you for going in that order. Okay. We have vertical angles. Oh my gosh. Oops. Have we written down 3 congruent statements that are side, angle, side? Yeah, we have 2 sides. We have 1 angle, and that angle is in between our 2 sides. So yeah, This is like the best proof ever. Triangle J and K is congruent to triangle M and L by side angle side. Okay. Now I'm not going to go completely through this proof, but do you see this quilt over here on the other side? Okay. PS and PQ are congruent. Let's go ahead and mark that. Okay. We also know that PS and PQ are parallel. I'm sorry, PS and QR. If those are congruent and parallel, how are we going to prove those two triangles are congruent with side angle side? What's one thing we know right away? We do know that. So we have purple triangle and orange triangle. Notice anything? PR is congruent to PR because of the reflexive property, right? What else is there? I wish, but we don't actually know that. Have we used our parallel lines yet? Hey, parallel lines, do they give us congruent sides or congruent angles? Yeah, parallel lines with a transversal.
PSR is congruent to PQR.
Actually, SPR and QRP are congruent because what kind of angles are they?
Alternate interior.
You know what I like to look for when there's alternate interior angles? The parallel line and transversal make a Z. Parallel line, transversal, parallel line. You see that? And in the Z, I have my alternate interior angles. Okay, that's something that you want to be on the lookout for. So we had to use the reflexive property for side PR. We had to use alternate interior angles for our parallel lines. Now we have side angle side. All right. Here we go. Go ahead and go to page 145. All right. I just want to remind you that if we have a right triangle, which one's the hypotenuse?
The one across from the 90-degree.
And then the other ones are both lengths. They're not maybe the same, but huh? Oh, hypotenuse. Okay, so this is saying, hey, if we have two triangles and all three sets of sides are congruent to another one, even if we know nothing about the angles, we can say, hey, these are congruent by side, side, side. If all three sides are congruent, then the triangles are congruent. You like that shortcut? Yes, I like that shortcut.
Even a person not looking at the thing and getting that, it's a very small amount of math. They know those are-
Think so?
Yeah.
Okay. So let me draw you a picture. Tell me what you think. Go and draw it. Do we have two congruent triangles?
Yes. DB is congruent to DB.
Okay, so you're saying that I can mark this right here, that we can say DB is congruent to itself because of the reflexive property, right? So in the end, I can say that triangle ABD is congruent to triangle I would say CDB by side. Why did I say CDB instead of CBD? Okay, AB and CD are the two sides that are corresponding. So we need to make sure that they're corresponding in our congruency statement. Okay. All right, so we're gonna kind of flip back and forth. What I want you to do, I want you to turn the page. We're gonna come back to this page for something. But I want you to look at these four right here. And I want you to determine if these statements are true. If so, we have two options. We have side, we have side, angle, side, or we have not congruent. So I'm gonna give you about 60 to 90 seconds for you and your elbow partner to decide, do we have congruent triangles or not, and why? It's really that startling, huh?
Or when you stand up, it looks like someone, like in the corner of your eye, it looks like someone there. Yeah, what's the point of this?
S. Is this SSS?
There's no S in this.
All of it.
Okay, is number one, are they congruent?
I think.
Yeah, they are.
Yes.
Side. Now, but what's special about the triangles?
They're both isosceles.
They're both isosceles, and that's okay. It's okay. What about number two? Are these congruent? Okay, we have to use a reflexive property And now we have side, side, side.
All of them can be side, 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 besides fourth one, which should be also SAS.
Okay, hold on, we're not there yet, Clark. Okay, number 3, are these congruent? Why? Okay, we should instead have triangle UVW congruent to what?
Oh.
Now we can say they're congruent by side, side, side. Good job, Presley. Okay,
I just, never mind.
now, what do you need?
Never mind. I'm just done right now.
Now, what? Oh, we're just gonna go with it. Okay, now Clark said this could be one of two. We could say side, side, side. But we have vertical angles here, right? So if you wanted to say side angle side, you could. Okay, it appears my tissues are gone. Do you need one right now?
No, I'm okay.
Okay. Let's go back to page 145 and I want to talk about one more theorem. Okay, called the hypotenuse leg theorem. If I'm talking about hypotenuse leg, what kind of triangle am I talking about? A right triangle. So if we have a right triangle and we have a hypotenuse and a leg that are congruent, notice hypotenuse, leg with that right angle, then we have triangles that are congruent. Now, the kicker is though, they have to be right triangles, okay? So with every proof, there's 3 things that you need for information. So far, we've talked about side, 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 angle, side, right? Those are 3 pieces of information. Here we have hypotenuse leg, but you also better tell me that it's a right triangle. Okay. So to finish out our class period, we are going to go to 2 pages ahead to this number 6 right here, and we're going to prove that these 2 triangles are congruent. Okay. So how about you go ahead and let's everybody write down the given information here. Okay. Side angle side, 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 hypotenuse leg. Which one are we going to use? Hypotenuse leg. And they've already given us this right here. AB and EB. And what are those? Those are our hypotenuses, right? Okay. So we need 3 pieces of information. We have 1. We need hypotenuse, leg, and the fact that it's a right triangle. Hey, do we have right triangles? It says C and D are right angles. So we can say that triangle ABC and triangle EBD are right triangles. Because that's the definition of a right triangle. So there's that piece of information. All right. Now we need legs that are congruent. Can we say something about legs being congruent?
CD.
Ooh, how do you figure?
Definition.
Okay, so we have a midpoint, right? So definition of midpoint,
Does a bisector have to be like a straight line?
a bisector just splits it in half. Okay. Any piece of given information we want to try to use. So one piece gave us our hypotenuse congruence. One piece gave us right triangles. The third piece, B as a midpoint. Hey, that gives us a statement that we can say these two pieces are the same, which gives us our legs. So now we can say triangle ABC is congruent to triangle EBD by hypotenuse leg. Page 4 and 5 is your homework from your middle of what?